Hi, this is the continuation of the first part of this video lecture. In the first part of this video lecture, we have talked about the state reduction. In the state reduction, we have reduced the state diagram and corresponding state table. And in the later part of first part of this video lecture, we have assigned the binary number to the uh, states, and the states were described or represented uh, with the letters like A, B, C, D, E, F, and G. So uh, if you guys have not go through the first part of this lecture, I suggest you guys must undergo the first part of this lecture, so in order to understand this part of the lecture. So in the first part of this lecture, we have designed the reduced state table. Now in this lecture we will use that state table, and we will design excitation table. So from excitation table, I will use RS flip-flop to design a sequential circuit. Okay, in the last lecture we have a state table which is as follow. So we have given the present state, we have given the input, and we have given the next state. And in present state, okay, I'm deciding the most significant bit is A and least significant bit is C, and input was X, next state is ABC. So from present state and next state, I will decide the input of RS flip-flop. So here we will decide the flip-flops inputs. So corresponding to input and output, sorry, present state and next state and inputs, we have given output of the circuit. So the output, which is Y. So the present state, I will start from 0, 0, 1. When the input was 0, so next state, no change. Next state will remain on present state. So when, and corresponding output was 0. When the present state is 0, 0, 1 and input is 1, so you can see the previous first part of this video lecture. At the end of the video lecture, we have given this state table. So when input is 1, the next state would be 0, 1, 0. Now we have present state 0. So in this case, the output was again 0. Present state is 0, 1, 0. Output is input is 0. The next state was, so in this case, when input is 0, the present state was 0, 1, 0. The next state was 0, 1, 1. So when the present state is 0, 1, 0, input is 1, the next state was 1, 0, 0. So the present state is 0 1 1, input is 0. So in both cases for these cases the output was 0. When the present state is 0 1 1, the input is 0, the output is 0 0 1. Okay, when the present state is 0 1 1, the output is 1, the next state was 1 0 0. So when the present state was 1 0 0, again, okay, I have present state 1 0 0, the input was 0. So in these two cases our output is 0 and 0. When the present state was 1 0 0, the input was 0, so the output was 1 0 1. And when present state was 1 0 0, and input was 1, so in this case the next state was 1 0 0. And corresponding output in this case is 1, whereas for remaining cases it is 0. Now we have present state 1 0 1, input is 0, the next state was 0 0 1, and output was 0 in this case. And when present state was 1 0 1, input was 1, the next state was 1 0 0. So here how many flip-flops we have to use, we have to decide. So here we have given the number of states, 1 2 3 4 and 5. So and the each state can be represented by 3 bits, so we need 3 flip-flops. So here I have to use RS flip-flop. So this one is first most significant flip-flop. So this is SA, then RA, SB, the input for flip-flop B, and then RB, SC, then RC. Okay, you guys remember the excitation table for RS flip-flop. If we have given present state Q of t and the next state is Q of t plus 1, and we have to decide their inputs. S and R. So when the present state is 0, next state is 0, we have input S is equal to 0, R is don't care. When the present state is 0, next state is 1. So in this case, S is 1, set button is 1, reset is don't care. When present state is 1, next state is 0, must reset should be 1, and set should be don't care, must be don't care in this case. So when present state is 1, next state is 1, we have set is don't care, reset is 0. So here we have, from this excitation table, I will decide the flip-flops inputs. So let's start from A. The present state is 0, next state is 0. So S is 0 and R is don't care. When present state is 0, next state is 0, same. Set is 0, reset is don't care. Present state is 0, next state is 0. So here the present state is 0, next state is 1. So in this case, we must have S should be 1 and R should be don't care. Okay, now the present state is 0, next state is 0. So in this case, set is 0 and reset is don't care. Present state 0, next state 1 again. So sorry, here we have an error. So I'm sorry, here I have an error in this excitation table. Sorry, I wrote this for JK flip-flop. Let me revise this excitation table. This is 0 and don't care. When present state is 0, next state is 1, set should be 1, reset should be 0. When the present state is 1, next state is 0. In this case, I'm sorry, I have a glitch here. So here present state is 1, next state is 0. So in this case, reset should be 1 and set should be 0. When present state is 1, next state is 1. So in this case, set is a don't care and reset must be 0. Okay, when there is a reset is 1, so the next state must be 0 in that case. So here I have a glitch. So I will replace reset with 0. Here the reset is 0 because the present state was 0, next state is 1. Here present state is 1, next state is 1. So in this case, I will use S is don't care, set is don't care, and reset must be 0. So in next case, when the present state is 1, next state is 1, again set is don't care, reset is 0. When present state is 1, next state is 0. In this case, reset should be 1, whereas set should be 0. Present state is 1, next state is 1, so set is don't care and reset is 0. Next for B flip-flop, so here the present state 0, next state 0, so set is don't 0, reset is don't. Next the present state is 0, next state is 1, So input 1 0. So present state is 1, next state is 1. Here you can see. So this is the set is 0 and reset is, in this case, set is, sorry, set is don't care and reset is 0. And again the present state is 1, next state is 0, reset is 1, whereas set is 0. Present state was 1 and next state was 1. So sorry, the present state is 1 here and next state is 0, so is okay this input. Present state is 1 and next state is 0. In this case reset is 1 and set is 0. Present state is 1, you can see here, next state is 0, so set is 0, reset is 1. Here the present state is 0, next state is 0. When the present state is 0 and next state is 0, in this case what should be, present state is 0 and next state is 0, so I will use set is 0 and reset is don't care. Present state is 0 and next state is 0. So set is 0 dot and reset is dot. Present state 0, next state 0. Also present state 0, next state 0. Now move to the third flip-flop. So in this case present state is 1, next state is 1. So when present state is 1, next state is 1, reset is 0 and set is don't care. Next case present state is 1, next state is 0, so reset 1, set is 0. Present state 0, next state 1, so set is 1, reset 0. Present state 0, next state 0, so in this case set is 0, reset is don't care. So here the present state 1, next state 1, so in this case set is don't care, reset is 0. Here the present state is 1, next state is 0. When the present state is 1, next state is 0, so I will use 0 1. Present state is 0, next state is 1, so here 1 0. Present state 0, next state 0, so when present state 0, next state set is 0 and don't care. Present state 1, next state 1, so this is the don't care and this is 0. Present state 1, next state 0, so this is 1 0. Sorry, here uh, the output was missing, so next we will next I will use a Carney map to simplify these flip-flops inputs and give an output. Okay, now let me simplify first. Let me simplify for uh, the input set SA. So in this case, so I will use a Carney map. So how many inputs? I will use this inputs A, B, C and X. So here in the column I will use AB, and in the rows I will use CX. So here I will simplify SA. So flip-flop input SA, so 0 0, C and X are 0 0, 0 1, 1 0 and 1 1. AB have 4 combination: 0 0, 0 1, then 1 1 and 1 0. So for 0 0 1 we have a don't care. For 0 sorry 0 0 0, for 0 0 0 uh, uh, this for 0 0 0, I mean it does not exist, so we will use the remaining combination. I mean total, I mean we have a 4, there should be a 16 combination for A, B, C and X. I mean these 4 bits we have a 16 combination. So here we have 1 2 3 4 5 6 7 8 9 10. So the remaining 6 combination would be don't care. So this one I am using a don't care. This combination does not exist for 0 0 1. So this is also don't care. And uh, again for combination 0 0 1 0. So I have SA is 0. And for 0, sorry, there is one glitch over here. This is 1 0 and this is 1 1 1. So 0 1 1 SA is 0. So 0 0 1 0, this is 0. 0 1 0 0, this is 0. 0 1 0 0, this is 0. And for 0 1 0 1 0 1 0 1, SA is equal to 1. And for 0 1 1, this is 1. 0 1 1, this is 1. And for 0 1 1 0, this is 0. And for 1 1 0 0 1 1, you can see 1 1 0 0, this does not exist, so I will use don't care. 1 1 0 1 does not exist, I will use don't care. And for 1 1 1, this does not exist, so I will use don't care. For 1 1 1 0, it does not exist, so I will use don't care. 1 0 0, this is for this case SA is a don't care, and 1 0 0 1, this is a don't care. You can see from the table 1 0 1 1, this one. So this is a don't care. So 1 0 1 0, this is 1 0 1 0, SA is equal to 0. So I can simplify this table. So after simplification, I can simplify this. These four boxes are adjacent, so these can be simplified. After simplification, this A prime will cancel with the A, so I will get B, and this C complement will cancel with C. So SA is equal to SA is equal to B BX. Similarly, you can work for RA. So for RA, so I will do it fast. So this is the don't care, 0 0 is a don't care, this is a don't care. You can see it from table, so this is the don't care, and this is the don't care, this is the don't care. So this box, this is 0, this is 0, this is the don't care, and this table, these all values does not exist in the excitation, this excitation table. So this whole row is don't care, all the boxes in this row, so this is the don't care. Then this is 0 0 0 0. So sorry, this is 1. When combination is 1 0 1 0, so you can see here 1 0 1 0, so RA is equal to 1. So to simplify this column, so here this column will cancel out, so RA is equal to C into X complement. Okay, now I will work for SB. For SB, let me modify this Carney map. So SB in this case, you can see from table. So this one is sorry, this one is don't care, this one is don't care. Here SB is 1, here SB is 0. This one is don't care. Here SB is 0, SB is 0. So for this combination SB is 0. And you know this whole line, I mean this does not exist, these combinations, so I will use don't care conditions. So remaining whole line, this one is 0. So these two boxes are adjacent, so after solving this I will get SB is equal to A complement B complement. Here x prime will cancel with x, A complement B complement into C I will get, sorry, A complement B complement and C complement. A complement B complement and C complement. Now here I will work for, sorry, here you can see the A complement B complement and here we have, sorry, C complement will cancel with C, so here I will use X instead of C complement. And similarly you can solve for RC. So let me erase all these values. So for RC, so for RC, sorry, SC, I am going to solve for XC. So this is the don't care, this is don't care, this is 0, and this is don't care, this is 1, this is 0, this is 0, this one is don't care, and this whole row, this combination does not exist, so I will incorporate don't care. So here SC is 1, then 0, for this combination 0, this is don't care. So here you can see I can simplify the first column with the last column. So when I will simplify this, this whole column will cancel out. So here you can see that the C complement will cancel with C, so I will get SC is equal to X complement. And then again Similar fashion, you can solve for RB, reset button for flip-flop B, which is equal to this output you will get. It's simplified form, you will get BC plus BX. And similarly for RC is equal to and finally let me solve for this output Y. So this output Y, the first 00 does not exist, this is don't care, 001 is don't care, and this, I mean, we have 6 combination which are don't care, so I'm filling those combination first. So for these combination, I mean these combination does not exist, so I'm filling it with don't care. Now the Y is equal to 1 for combination 1001. This is 10 and this is 01. Here Y is equal to 1 and Y is output is 1 when is a combination 1011 1011 for this one. So for remaining it is 0. Now I have to simplify it. So these 4 boxes are adjacent. So by simplifying it here, this B will simplify. I mean B will simplify with B complement. So Y is equal to A, and here C prime will complement. C complement will simplify with C and I will get X. So Y is equal to A of X. Now let me draw the sequential circuit. I'm going to erase this excitation table. So I have, let me erase these, I mean these Carney map tables also, and this Y is equal to, so I have a 3 RS flip-flop. So these have a common clock pulse. I'm going to use their common clock pulse. And these have, each flip-flop has 2 input, S and R. So this is SA and RA. This is a flip-flop B, so its output is A. This output is B, so its input again SB and RB. So this output is C and its input SC and RC. So first let me design this output, which is equal to, okay, I have this one is external input, which is X. So this output is AND with this, the output of flip-flop A, and with this external input X. So this is the Y, which is equal to, which is AND of A and input X. Now the flip-flop input SA, which is equal to B into X. So B is the, I will use AND gate here. AND gate, and for RA I need to use another AND gate, and for SB I need AND gate, 3 input AND gate, and for RB I need 2 AND gate, and 1 OR gate. So these AND gates will OR and for SC, which is directly connected to the complement of input X, and RC is directly connected to the complement to the X. So here first for SA I will connect this output B, so this is output B and this is X. So this is the B of X. So this AND gate I'm going to connect with the SA, and this SB is equal to sorry RB is equal to this, RA is equal to C into X prime. So this is C into X prime. So this is the complement of input X. So I'm going to connect here, and so next for SB, this is A complement B complement into X. So I need a 3 input AND gate. So this is the this is the A complement, so this is the A complement. I'm going to connect this A prime, okay, then I have to connect this B prime, and I have to connect this with X. So, and we know that RB is BC, so I have to connect it with this B, and this is the input, this is the C, this is the BC, and which is R with the BX. So this is the R with the, this is the B, and this is the X. Now it's okay. Then RC is connected with the X, so it is directly connected with the X, and SC is connected with the X prime. So here this wire I can. So this is the logic diagram of our sequential circuit. Now you guys can do analysis. That's it. Thank you very much. So this is the logic diagram. Yet I have this difficulty in writing on this digital board.